Now we move on to third order determinants, which are really just an extension of the second order. So if you've got the second order down and you understand it, the third order just adds another layer to the mix. So this determinant has 3 rows and 3 columns, where the other had 2 rows and 2 columns, and is considered to be the third order determinant. So you can see we've got 3 terms as well as the constant in each expression. So in building this one, you can see that, again, the denominator is the same in the solution for each of the x, y, and now z terms. So the numerators are different in each. So the numerator in the x term has the constants, the b terms, and the c terms. The y solution has the a terms, the constant terms k, and the c terms. And then the last one, the a terms, the b terms, and the constant terms. So you can see really all we're doing is, since we're solving for what would normally be the first value here in the x values, we need to create then an array that does not include that so that we can in fact solve for it. So to solve for these expressions, you can see it's just a little different. Let's look at the denominator first. So the denominator solution is A1, B2, C3 as a product. So we go right through the middle diagonal of that term. The second term is B1, C2, A3. So we move over 1, B1, C2, A3, which is over in the bottom left-hand corner. Okay, notice we're adding, subtracting, subtracting. Okay, so on the third term, we have C1, A2, B3, and then on the next one, we have A1, C2, B3, and then B1, A2, C3. Okay, it seems a little confusing, but once you get it down, it's the same process over and over again. You'll notice for the numerator then, it becomes the same thing. The center diagonal, K1, B2, C3, B1, C2, K3, and so on. So we're adding, subtracting. So we do that for each of our variables that we're solving for. And you can see here, a quick and easy way to do this is they tell you if you just move out your terms for K and B and continue with the diagonal decomposition or resolution, it makes more sense. And you can see in each case which ones are added and which ones are subtracted. So various methods are used to find values x, y, and z. Here's one of them. Rewrite the columns 1 and 2 to the right of the determinant. For the unknown x, the numerator then would look like this. The diagonal lines have been drawn through the elements whenever there are 3 elements in the diagonal group. Where there are fewer than 3 elements in the diagonal group, that diagonal group is not used. The result is 3 diagonal groups running down from left to right, and the 3 diagonal groups running down from right to left. The products of each diagonal group running down from left to right are added. The products of the groups that run down from right to left are subtracted. This procedure is used for each numerator and each denominator. Since all the denominators are alike, however, the denominators need to be determined only once. So you can see on this how writing a solution in Excel, or if you've got a programmable calculator or a calculator that has determinants built into it, you could probably do that. I haven't looked at your calculator that I suggested, but I suspect it has a determinant function built in. Most scientific calculators do. So when we come back, we're going to take a look at an example of a third order determinant and seeing how we put this together with three expressions.